Okay, let's finish up the lecture from last time where I was suggesting that the choice of language can actually steer a programmer's decision. And I'm saying this as a counter to the argument of you can write your Java program in any language, which is true, but not how it usually works out, is what I'm saying. Okay. And last time, just recapping, I used arithmetic as the example, and we saw that we looked at several different languages, Java, Python, Racket, and Sage, and we looked at arithmetic in them. And Java doesn't do 2 billion plus 2 billion correctly by default. You can get it to do it correctly, but you have to type a lot more, and programmers are not encouraged to do that. And in practice, I sure don't. I'll use an int or a long, but I'm not going to bother using Java math big integer. Okay. Python. Python does big integers transparently. You just use the numbers and they get as long as you like. But rational arithmetic goes bad. So we looked at 7 divided by 25 times 25. And Racket did that correctly and exactly. Okay. And then we looked at irrational numbers. Okay, so square root of 5, and we saw that Java and Python and Racket all use doubles, IEEE doubles, which can give the wrong answer. So in particular, the square root of 5 times the square root of 5 is not exactly equal to 5. While Sage does understand that. So we saw that it's not that a computer can't do any of these things, but certain languages give you, and I think we ended up talking about this as a trade-off between the correct answer and maybe a more efficient answer. And we saw that if you're repeatedly multiplying something by 0.95 by 19/20ths over and over and over again, you could be exact and keep track of the exact arithmetic. But if this is, say, part of a video game and a friction component or something slowing down, yeah, multiply a number by 19/20ths 100 times, you now have an exact rational that's hundreds of digits long in both the numerator and the denominator. And doing another multiplication is actually starting to take a lot of time. And if you don't need that time, then you could trade off to using an inexact number. Racket makes that choice explicit. Java does not. Well, put it this way. Java gives you that choice, but they steer you towards the incorrect math that is efficient as their first choice. And I think that's backwards. I think the default thing a language provides should be the correct answer, perhaps inefficient. And if you need efficiency over correctness, then go and do some extra work to tell the language you want that. So, okay. And I did want to mention that we did see something interesting in Sage. We saw the function n. N takes in a number, and like we said, n the square root of 2, because if we just tried to evaluate the square root of 2 in Sage, the square root of 5, it came back and said the answer is the square root of 5. But we could call the function n, pass it the square root of 2, and if we wanted to, we could optionally pass it digits equal 50. And it will come back and give us the numeric approximation to 50 places. That's what the function n does, gives you the numerical approximation of your number to a certain number of places, with a default of 10 places or something like that. And I just wanted to mention, this being a language class, this passing at digits equal 50, it turns out with the function n, there's quite a few different things you can pass that function that tweak how it behaves. And in Java, we're used to functions that say, hey, I might overload a function. There might be a simple version that just takes a single argument, and another one that takes 12 different arguments with all the things. I'm thinking of the Java windowing system, just making a new component, and you have to specify its name and its parent and the size and 20 or 30 other things. Many of which have defaults. So what do we do in that case? Java says, okay, I'm only going to provide a constructor where you provide the one required, and then you need to call a setter many, many, many times. So you construct an object, and it may not be the one you want to construct, and you need to go tweak it after the fact. If you had a constructor that had all 20 arguments, gosh, you could do it, but you have 20 things, and you have to, as a programmer, like, how are you going to remember the name of the width of the frame? Is that the 7th argument or the 8th argument? I forget. And that's just a waste of time to go look at that up. But we're used to in Java passing arguments by position. Okay, that is, we have 20 arguments, and so you have 1 through 20, and some of the later ones might be optional and have defaults. This is a different model. This is saying, hey, this is calling by keyword. There's a required argument that's by position, the very first argument, which is the number you want. But then you can have a bunch of other things that you pass, the function n knows of certain keywords it recognizes, and digits is one of them. Say, oh yeah, digits by default is 10, but if you include that in the function call, I'll use 50 instead. And so that's just interesting, and it's again, if you only use Java, if that's the only language you ever see, you might never think of this. And the moment you see it and use it, it's like, wow, that makes sense. And the moment you really use a language that has it a lot, Python has this, it's awfully hard to go back to a language without keywords. Okay, so anyway, that's a little language note. Okay, so again, we were talking about numbers and how they steer a programmer a certain way. By the way, we mentioned this briefly, but how does it work? How does, say, Python keep track of arbitrarily long integers? And we suggested that probably, I'm guessing, it probably keeps a list of digits behind the scenes. So the type for an integer is not just a 32-bit or 64-bit word in memory like it is in Java, but overflows. It's maybe a linked list of digits, okay? So, and it might be digit space 10, it might be digit space 1,000. That way that way you can have three decimal digits in a single linked list container. It's probably more like a linked list of 32 bits, 32-bit digits, if you will. Okay, and that's what Java Math Big Integer does, okay? It's just that Python made that the integer version that it looks like on the surface, okay? And similarly with Racket, how does it allow exact fractions? Oh, it keeps a structure of size to it. It's going to keep track of the numerator and the denominator internally, and so the real numbers, you don't use a double, you have some other rational number, and that is a structure with 2 fields that is kept and passed around internally. And you can't really tell it from the outside, and that's just fine. Okay. If you think about how it works under the hood, ultimately when you want to multiply numbers, add numbers, you go to the hardware, the computer hardware, okay? And those need 32-bit ints, 64-bit doubles, whatever. That's what the hardware is supporting. So if you're supporting something else internally, you need to rewrite it. And if you want to multiply 2 large numbers, you can do it, but you'll have to, at the end of the day, work it down to multiplying 32-bit numbers or 64-bit numbers. And that's very quick if you can use that hardware. So you might want to say, hey, I want to be kind of fancy. Integers are a very common data type. I want to use 32 bits for my int. Oh, except if the int gets too big, then I want to use a really long structure. And so here's what actually happens internally. The way Racket works is most data types are actually a pointer to a fancy data structure. But integers are, well, they're a 32-bit integer, something like that. Maybe not 32 bits, maybe 31 bits. And it turns out, here's what they do. The lowest bit, if that lowest bit is a 1, the rest of this whole thing is going to be an integer, a 31-bit integer. If that lowest bit is a 0, then it is a pointer to a bigger data structure that might be the linked list of digits, actually a bigger data structure that probably has a tag telling you what type of data it is, okay? And so now if you're on the hardware and you actually need to add a couple of ints, what Racket does in the code when it comes to multiply says, hey, look at this int here. If that lowest bit is a 1, shift the whole thing over, that whole bit's over, and now I have a primitive machine int, a 32 int, an int 32, I can call this. And once it gets 2 int 32s, then it'll go ahead and use the built-in circuitry for addition or whatever, keeping track of overflow. But yeah, so you're actually keeping extra tag bits around so you know what type of data you have. Anyway, okay, I'll talk more about that later. I'll come back to that and describe it better, I think. Okay, anyway, I wanted to just finish up by saying, okay, arithmetic, great. Arithmetic, yeah, maybe you've kind of maybe convinced me that how a language handles arithmetic steers a programmer to use inexact numbers for convenience when they know they shouldn't. I'm going to talk about data types briefly. And I'm going to say Java kind of encourages you to use arrays, even if a list would be a better data type. Okay? So, now first of all, we'll come back to saying what's really the difference between an array and a list, but let's ignore that for now. There's a lot of overlap in what they can do. Lists can do a lot of additional things that arrays can't do. The bottom line is arrays are fixed size and have a different syntax in Java than objects. I'll come back later to talk about what I mean by that. But suppose I just want to make either a list or an array. I just want to keep track of 5 different numbers, okay? 22, 17, 24, 30, and 5. Okay, great. Gosh, to do this as a list, kind of tedious. Okay, I have to declare a new list, construct it, then call the add method 5 times in a row. I can't just call in the constructor and say, hey, here's the 5 things I want you to start my list. Whereas with arrays, you can do that. Arrays has a syntax that lets you do that. It's a special syntax that's hard-baked. It's only arrays that do this in Java. And you know, it makes me want, if I just need to have these 5 numbers, I'm like, yeah, a list, I may want to do things, and the list data types are more appropriate, perhaps. I'm going to use an array if I can get away with it, because it's so much easier to write. I can do it all in one line, and it looks concise, easy to tell what's going on. So, okay. So arrays are, easier to declare in Java. Accessing them with a list, I have to call the element at method or something like that. If I want to get the item at index 17, I have to do list get of 17 or get at 17, something like that. Whereas with arrays in Java, I use square brackets, and I don't even have to type dot get open paren, anything like that. They both do the same thing, but the easier syntax steers me to say, hey, yeah, these arrays are really convenient. Okay. There are a lot of built-in functions in arrays or in Java that use arrays, or the string.split method. Okay, breaks a big string into individual words by white space or something like that. Returns an array. Doesn't return a list. Returns an array. Okay. If I'm doing a lot of work and taking the result of that and passing it off to my function and using that result and passing it off somewhere else, it might just be easier for me to use arrays, again, even if I think a list would be more appropriate. So, okay. And I'm not really talking about array versus list. I'm saying, hey, a language is steering me to use one data type rather than another. Okay? So, I will say that there are other methods in Java that try to help using arrays, and they've added things. There's third-party libraries that make using lists a lot easier. And you can always take an array and turn it into a list. So here's an array. I make an array, and then I can call the asList method to do that. In fact, I could even do that in line. If I want to make a list of numbers, I could go ahead and just write literally arrays.asList and then make this new anonymous array, little array, I'm not sure what you want to call it. I'll make an array right there and pass it as my argument to asList, never giving that array a name. Okay, and that's a little bit better than having to do the .add. Still feels weird. I'm jumping through hoops. The language is making me jump through hoops to get what I want. Either I have to call add 5 times, or I have to call, make the array anonymously, pass that as an argument to arrays.asList. Okay. It turns out there are even some other, in Java 10, they finally came out with a method list.of. Takes in as many things as you like, returns a list containing those items. That's what I wanted. That's what I wanted. Java 10 even introduced the var keyword, so if it knows the type of the right-hand side, and it knows you're declaring a new variable and putting this result into that variable, it says, I'll infer the type from the right-hand side. You don't have to tell me again. Just say var, and you're making a new variable, and I'll figure out what type it is. Java's still very aware of the type. There's still a type to this variable. It's just I, the programmer, am not writing it. I'm letting the compiler infer it for me. So, okay. By the way, you can go ahead and read this warning. These functions asList and list.of are really handy, and they work really well when put together with a lot of the other new things that have been added to Java recently. However, they return lists that don't have certain methods that lists should have. Rather, they have, it is something of type list, but if you call the add method, if you take this list and now try to add something in the middle of it, that is supported by a list. However, it will throw an unsupported operation exception on this particular list. That just, don't call it a list if I can't call the list methods. That's what I want to say. But Java has their rationale, I guess. Okay. So that's an example where I'm saying overall, when I'm using Java, I kind of want to use arrays for things because it's built in, it's easier than actually calling methods and calling libraries to use other data types, even if they're more appropriate. Okay. Conversely, I'll look at Lisp or Racket. Lisp encourages you to use lists even if arrays might be better or some other data type might be better. Why? Lisp, actually the name Lisp comes from list processing, and it has syntactic shorthand to make lists super, super convenient to use, and it has a very rich library of functions that work with lists, very flexible. And so I'm not going to talk about the function so much, but the syntax for making a list. I could go ahead and call a constructor, like, hey, here's a constructor. You call the list constructor, and I pass it the 4 things I want in the list. Not bad, not bad. In this case, I have a number, a symbol, which is kind of like, think of it as an enumerated type, if you know what that is and care. Another number, another symbol. Okay, instead of doing that, it turns out I can just write a tick mark in front of the parentheses and get the same thing. Okay, it turns out the tick mark sort of distributes over everything in the list. So I still get iBarland as a symbol. But okay, anyway, and this is especially convenient if I'm making lists of lists, if I'm making a really big complicated list structure. So here this is not an uncommon thing to do. I have a bunch of records about various classes, and each of those records is a list, and then I'm making a list of those records. Okay, so a list of lists, no problem. Yeah, using that quote syntax, that just falls out super nice and easy. Okay. So, gosh, using Lisp, I am encouraged to use lists because it's so easy to write things like that. Actually, in maybe not Lisp, in Racket, arrays, which they call vectors, also have a shorthand that's just as good as this. And I should also mention there's in addition to that quote mark, there's back quote, which can do some really fancy stuff. There's a link in the notes there. So, gosh, in Lisp families, or in Racket, yeah, there's a shorthand way to make lists, but there's also a short way to make vectors and hash tables and some other data types. Sets, or I have to type a little bit more. But, yeah, okay, I have those. But it turns out everybody using Lisp languages tends to use lists a lot because they're convenient. So there's a rich library, a rich group of third-party libraries for processing lists. And so if you have some data and you might think a vector is the right way, an array is the right way to use, or an array of an arrays, But now you want to use all these other helper libraries that are written, and they all want lists of lists. Okay. Yeah, the language is pushing me to use lists, even if I don't think that's the right data type. Okay, so these different languages have different ways they push you in. And I'm just going to wrap up with a special mention of Python. One thing that people really love about Python, and is really awesome, is that they have, first of all, convenient shorthand for the 4 most common data types. Okay, lists, tuples, sets, and dictionaries. Okay. So yeah, if you want to make a list in Python, it's awfully easy to make that initial list and work with it. Tuples, sets, parentheses. And the other thing that Python does well, that Java also does, is has a fairly uniform collections library. So sets of functions that operate on lists, actually they're almost always written so that they work on any collection. They'll work on a list or a tuple or a set or a dictionary. And that's kind of nice. So Python goes a long way towards actually avoiding some of the nudges that these other languages have. So, okay, so I'll leave you with that to think about, with the idea that languages affect the programs you write. Okay, and seeing some of these other things, seeing the passing an argument by keyword rather than by position, easy ways to write lists, having these common library things. Once you see that in other languages, and you see what other languages make easy or difficult, that's when you start to understand what your language is making easy and difficult, whereas before you had no idea if that was true or not. So, okay, I will see you next time.